Hello students, good morning. We will continue this exercise 16.4 from question number 21. See, the solution is explained here. In the question it is given the inner dimensions of a closed wooden box. See, this one we supposed as a closed wooden box, and this one is the inside cuboid, that is the inside part of the box, and for that inside part we have the dimension here. You can see 2 meter. See, here it is 2 meter, that means the inside part. Okay, and here it is 1.2 meter, that one, and that height, that may be considered the height, that one of the dimension, that is 0.75. so we have the three parameters, so we can calculate the volume. The inner volume is equal to 2 into 1.2 into 0.75, so we have the inner volume as 1.8 meter cube. Now the thickness is given as a 2.5 centimeter, so it can be converted into meter as 0.025 meter. So as we have the thickness, so we can calculate the outer dimensions, that means the dimensions for the outer cube, the outer box. Okay, so outer dimensions of the box is given here. You can see it is calculated here. 2 plus 0.5 0.025 plus 0.025, that means here lengthwise you can consider this thickness. This thickness is 0.025 meter, and this thickness is also same, that is 0.025 meter, and this one is given as the inner dimension, it is given as 2 meter. So first we have this 2 meter, that this complete one 2 meter, and then after this one is added 0.025, and that one, this one 0.025. so see here at the bottom it is added, so we have 2.05 meter as one of the dimension for the outer cube. So in this way we have calculated the other dimensions also. See here 1.2 plus 0.025 plus 0.025, so we have 1.25 meter, and that one is 0.75 given, and it is added with 0.025 plus 0.025, it will 0.8 meter. So now we have the outer dimension. See, the outer dimensions of the box is 0.025, sorry, 2.05 it is, and 1.25 and plus 0.8 meter, correct. So we can calculate the outer volume by multiplying those. So see, the outer volume is given 2.05 into 1.25 into 0.8, it gives, see the last line, it gives 2.05 meter cube. So now we have the outer volume and we have the inner volume. So what we'll do next here, see the inner volume this one and the outer volume is this one, so the remaining volume can be calculated by subtracted this inner volume from the outer volume. So see here, this outer volume, from this outer volume we have subtracted the inner volume, and we have got here that one 0.25 meter cube. So this 0.25 meter cube, that means this 0.25 meter cube gives the volume of that cube, that wood, that thickness of the wood, correct. We are considering only this thickness, and inside part is vacant, it is closed, but the inside part is vacant, correct. Now here 0.25 meter cube is the volume of the wood. So cost of wood is given rupees 5400 for 1 meter cube. Okay, as we have the volume this much, 0.25 meter cube, so it is multiplied with 0.25, and we have the answer. Yeah, it is 1350 rupees. 1350 is the cost of that wood that used in this closed box, correct. The box is closed. So now see the next. Here we have the question number 23, because question number 22 you can solve by the same idea as we have solved the question number 21. So here question number 23, the solution is explained here. In the question it is given, this one is a brass sheet, okay, and the brass plate, and it is this is a square surface, okay, and the thickness is given 1 mm. So 1 mm can be converted into centimeter by 1 by 10 centimeter, and this one is given as x centimeter, correct. So if we want to calculate that area, that surface area, that will be x into x, that is x square centimeter. And remember one thing, when we want to get the volume, we are just multiplying that area with the height or depth, correct. So here this area is uniform for each length, each height, correct. Here it is continuous up to 1 by 2 1 by 10 centimeter. So this area, this is area x square, is continue, is uniform up to 1 by 10 centimeter. So that's why you know that this one is volume, and volume is equal to area into thickness, correct. So you can use this one, area into thickness. So here area we have x square and thickness is 1 by 10. So if those are multiplied, then we have x square by 10. See, this is the area, this is this area, and this 1 by 10 centimeter is the thickness, correct. So if those multiplied, we have here x square by 10 centimeter, cubic centimeter is cc, means cubic centimeter, correct. Now it is given in the question, cost of brass is 8.4 gram for 1 centimeter per 1 centimeter 1 cubic centimeter, correct. And we have the volume as x square by 10 cubic centimeter, and we have to find out the value of x, correct. So from this question we can write this one is the cost 8.4 gram for 1 cubic centimeter. So this is, we can just use the idea of proportion here. 8.4 gram by for 1 centimeter cube, 1 cubic centimeter, and it is equal to, yeah, 4725 gram. That is given as the mass of that sheet. That is given in the question, 4725 gram for that volume. As we have calculated by our idea that volume of the sheet is that much. So as we have also the mass also, yeah, this one is given as the weight, correct. So we have the weight for that much of volume. So see here, 8.4 divided by 1 is equal to 4725 divided by whatever the volume, that is x square by 10. So if we continue this solution, if we continue with this solution, we have x square is equal to, see, 47, see the second last line, 4725, that means 47,250 divided by 8.4, and it is calculated as 5625, and then after x is equal to square root of that 5625, and it will give 75. So value of x is 75. As we have given in the question, x is a centimeter, so that means the 75 is centimeter, is actually centimeter. So value of x is 75, correct. So this is the answer. Now we go to the question number 24, and I have given the hint only for the question number 24, because in question number 24 you have the 3 individual cubes. So and those are to be recasted into a big single cube. So here use the idea that sum of volumes of each of those 3 cubes is equal to the volume of the big single cube. So you know the volume of the cube, you know the formula for the volume, it is side cube. So just use the formula individually for 3 cube, and then after add those and equate it with the bigger cube, with the volume of the bigger cube, and then you will get the answer, value of x. X is to be find out there. And now see, question number hint is given for question number 25 also. Here the volume of water per second, as because you can see here you have the area and you have the length. So if you multiply the area with the length, you will get the volume, and that one is the volume of water per second. That whatever you have calculated by the given term, that will be volume of water per second, but it is given that for 1 minute. It is asking in the question, it is asked in the question, for 1 minute you have to calculate the amount of water. So here that volume of water per second is multiplied with 60, and that will give volume of water flowing out per minute. So use that idea, read the question, you will understand. And one more thing that you have to use here, this is the relation that 1000 centimeter cube, this is the volume, 1000 centimeter cube can be equated as 1 liter, correct. So use that idea, whatever centimeter cube we are getting, just equate that one with 1 by, that multiply with 1 by 1000, correct. So as because here you have 1000 centimeter cube as 1 liter, so 1 centimeter cube you can write 1 centimeter cube is equal to 1 by 1000 liter. So use that relation and you can get the answer. Now I'm going to the next question. This is question number 26, and this one is the first bit, because we have 3 bit here, and I have solved the first bit only. Here this is the figure given in the book. So we can consider here 2 solids. This one is the solid lied horizontally, and this one is the upright vertical solid, correct. Now as from the previous part, we have the idea that if we multiply the cross sectional area with the length, as because this cross section is uniform, this red mark, this is red cross section is uniform up to that length. So for the calculation of that volume of that solid, we can use that formula, that this cross sectional area, that means this 2 into 4 gives that area, correct, and that area should be multiplied with that length. Okay, because this area is continue, this area is uniformly continuous up to that length 4 given here. Now we have the same area of cross section here also, so we can also use the same idea, and that area of cross section is multiplied with that uniform length. That means this cross section is continuous up to this 6 centimeters, so this is to be multiplied with 6 centimeter, correct. So first thing is to be measured here, that area of cross section. See, easily we have calculated. Consider two sides each of area of cross section for 2 into 4. Yeah, that one is 2 into 4, that one is also 2 into 4. So 8 centimeter square is the area of cross section, and we know that volume of solid with uniform cross section is equal to area of cross section into length. That means the length up to which the area of cross section is continuous uniformly, correct. So here we have the volume of one solid, that one we can consider. Okay, so here 8 centimeter square is the area of cross section, and it is multiplied with that length up to which that continues, that area of cross section continues, that is this length, correct, this length, this area of cross section, and it is continuous up to that length 4 centimeter, correct. So here 8 centimeter square is multiplied with 4 centimeter, and we have 32 centimeter cube as the volume of that one. Now we have that one also, that vertical upright cube solid. So just calculate for this also. Volume of the second solid is 8 centimeter square into, this one is 8 centimeter, the area of cross section, and it is continuous up to that length 6 centimeter. So 8 centimeter square into 6 centimeters, then after it is multiplied, and we have got here that 48 centimeter cube. So now we have the two individual volumes for the two individual solids. So just add those. The total volume is given. See the second last line. Total volume is 32 plus 48 centimeter cube, and that will give 80 centimeter cube, and that will be the answer, correct, of that. This is the volume of that solid, that given solid. Now I have skipped the question the bit B for that question number 26 and bit C, because here I have solved question number 27. See this solution, you will get the idea, and you can solve those two bits for question number 26. Okay, so as it is given in the question, a swimming pool of length 50 meter and 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 broad and wide, and the width is given 15 meter, correct. So that means this length is suppose 50, and this one is suppose, okay, you can consider this one as 15 and this one as 50, correct. So first of all, suppose we are considering that length as 15 meter, correct. Now the area of cross section here for the trapezium we can consider, because this one is the area of cross section, and this area of cross section is continuous up to that length, correct, and that length is, we are considering 50 meter, and this one is 15 meter, correct. So the area of that cross section is 1 by 2 into 1.5. You know the area of trapezium, this is the trapezium, this cross section is the trapezium, this cross section gives the shape of trapezium, so we are using that formula for the area of trapezium, that is 1 by 2 into sum of the parallel sides. This one is the this one, and this one is the parallel side, and this one we are considering, you can mark here 15 meter. Okay, just mark here 15 meter, because I have forget to mark here 15 meter, so just write down 15 meter here, that length. Okay, so you know how to calculate the area of trapezium. It is the sum of those two sides and into that length, that is the distance between the parallel sides. It is given here, correct. See, the formula is given here. So 1 by 2 into 1.5, this one is 1.5, and this one 4.5, and this one is multiplied with 15, that is the distance between the parallel side, and that will give 1 by 2 into 6 into 15, and 45 meter square is that area of cross section. Now in the question it is given, these are the depth of the pool, swimming pool, and this one is shallow end, depth of the shallow end, and this one is the deep end, correct, depth of the deep end. That two part is given in the question. So just see this, and here you must write that 15 meter, this one is 15 meters, so right here 15 meter, and that length is 50 meter, correct. Now we have calculated that area of cross section is 45 meters square, and then after, if you want to get the volume, then volume should be multiplied with, for the volume, the area of cross section is to be multiplied with that length up to which that area of cross section is continuous uniformly, and this length, many times I have told you, this length is 50 meter, correct. So we have the volume of the water filled in the pool is equal to 445 meter square, that is the area of cross section, and it is multiplied with 50 meter, and that will give 2250, that means 2250 meter cube, and this is the volume of the water. Okay, so this is the answer. But suppose if you want to convert this one into liters, then 1 meter cube is 1 liter, 1000 liter. So you just multiply this 2250, that means 2250 with that by this 1000 liter, and you will get the volume of the water in amount of water in liters, correct. So this what this 2250 meter cube is given as the answer. And remember one thing, you just mark here 15 meter and this length as 50 meter, 50 meter, correct, and this one is 15, 15. So this completes this exercise. So thank you class, have a nice day.